All right, here we go. Number 2. A modified Atwood machine consists of 2 masses. M1 is 8.2 kilograms. And mass 2 is 4.6 kilograms, connected by a massless string, right? That helps us not have to bother with it, which passes over a massless and frictionless pulley. Okay, you don't know any better now, but in another couple weeks, you'll know why that matters. Okay, but for now, we'll assume we don't care. Mass M1 sits on a table. Mass 2 hangs freely on the connecting string. Okay, all right. Again, look, I'm not even going to read the question because I don't even care what it says, because it's going to be exactly the same no matter what. All right, I want to set my positive direction, so I'm going to set it like that. Okay, so it's to the right for mass 1, okay, and down for mass 2. That all counts as the positive direction because we're looking at the direction of motion. Okay, so M1 is going to have FG and FN, okay, those are going to be equal, pulled by some tension, okay, and then pulled back by some friction. Okay, and I'm not going to bother with feeler dealer because it's not really necessary here. Okay, mass 2 is going to have FG, let's call that 2, we'll call that one 1, and then FT, okay, and remember that's the same, whoops, how about 2 dashes? That's the same string, that FT is the same string on both sides, okay, so that's the same force, okay? All right, now I will go ahead and start setting up my Newton's laws equations. Equals MA. Okay, and kind of call that the x direction too, I guess, all right? Because I don't really care. So in this one, I care about this direction, right? Because that direction and that direction are actually the same direction, okay? All right, now we better read it. Determine the minimum coefficient of static friction required for the system to remain motionless when released from rest, okay? So if we're talking about static friction, that means it's going to be equal to 0, all right? So the force of tension has to equal the force of friction. Okay, the force of tension is going to be mu Fn. What is wrong with this thing? Okay, Fn in this picture we can see is equal to the Fg1. Okay, and then if I want mu, I could call it mu static. I'm going to have Ft over Fg1. Okay, which doesn't totally help me because I don't know Ft, right? That's not given. So then I have to look at this side. Fg2 minus Ft equals 0 because it's not moving here either, right? It has to move or not move in both places. Okay, but the Fg comes first because that's the positive. Okay, so Ft is Fg2. Okay, and then I put these two together. Then mu s is going to be Fg2 over Fg1. Right, which is m2g over that. Okay, so the g's are going to cancel out. So I can see the static is just the ratio of their masses, right, which is 8.2. No, 2 is on the top. 4.6. Okay, divided by 8.2. All right. You see how it comes out to the ratio of the masses? I bet you like $100 it always comes out like that, right? Can't remember, but I guarantee you it does. It always comes out like that. Something cancels. Okay, 0.56. Okay, I got a number less than 1, but kind of on the biggish side since it's static, so that makes me feel pretty confident about that answer. Okay, remember if it's greater than 1, it's not necessarily wrong, but it's worth a double check. Okay. All right, next thing. Now suppose the system accelerates from rest. Okay, the coefficient of kinetic friction is 0.3366. Determine the acceleration of the system. Okay. I should have written smaller. I'm going to run out of space. Okay, so look, the whole setup is the same, right? It's just now the friction force would be smaller, right, than it was before. Okay, because it's going to move to kinetic. Okay, all right, but the setup is the same. So the Fx equals max, but now instead of being 0, right, I have to actually have it. So I have Ft minus Ff equals max. Or let's just call it A, right? Because that's fine. It's going to be the same for everybody. Okay, and then for the other guy, ooh, how am I going to write this? Oops. Fy, or no, I'm going to call it Y. F equals MA. So FG2 minus FT equals M2A. This is M1A. Okay. All right. So now I see I have acceleration in both. All right. And I have tension in both, right? So I have two variables and two equations. All right. So let me just go ahead and set up Ft equals M1A plus the friction. Okay, which is M1A plus mu M1G, right? Because that's the Fg equals the Fn right here. Okay, and then over here, let's plug in. Let me solve out this side for F. Well, should I solve out for Ft? No, probably not. That's dumb. Okay, Fg2 is M2G minus this whole mess right here equals M2A. Okay, you got to just be careful which ones you're talking about, okay? All right, now I know everything. Now I can solve out for A, okay? So let's do M2G minus M1A minus mu M1G equals M2A, okay? M2G, and you could put numbers at this point, but honestly, I would really practice not doing that. Okay, I'm going to move that to the other side because you're not going to probably be able to do that on the test, right? M2G minus mu M1G equals, see, here's this thing again, G minus mu M1G over M1 plus M2. All right, now I can go ahead and plug everything in. Okay, M2 was 4.6 times 9.8, 0.3366, 8.2, 9.8 over those total. Okay, and then like a miracle of God, if I can use a calculator, 4.6 times 9.8 minus 0.3366 times, I'm going to try to do this all in one line. Is this going to actually work? 8, okay, divided by 4.6 plus 8.2, 1.41. That seems reasonable. We'll see when I do it in class tomorrow if I get the same thing. Okay, so that'll be the acceleration of the system. Okay, and then I think it asked for the tension probably, right? Because it always does. Now look, I already have these nice expressions, right, already set up here for the tension. Okay, so Ft equals M1A plus mu M1G. And then now you know A, right? So you can just plug it in. So 8.2, 1.41, 0.3366, 8.2, 9.8. Okay, right? Make sure you get the difference between A and G, right? That G is like the newtons per kilogram. Okay. Okay, 8.2 times 1.41 plus 0.3366 times 2 times 9.8. Okay. 38.6. That seems reasonable. All right, so there you go. Looky there. That's it. Okay, so take a minute. I'll leave that in case you want to pause it before I stop the video.